CPT 209, Chapter 16, Networking Types, Devices, and Cabling. Here are the objectives. They can be found in your textbook as well. Network types and topologies. So your networks can be categorized by technology that is used and the size of the network. For example, a PAN, personal area network, that's going to be a personal thing, meaning it's probably going to be like a cell phone and a laptop or a desktop. LAN, local area network, is going to cover a small local area geographically. For example, the main campus would be considered a LAN because realistically I can walk from building to building. We're all on the same backbone. Therefore, that would be considered a LAN. A wireless LAN covers a limited geographic area and is popular in places where cables are difficult to install. We also have a WLAN on campus. The canteen area, some of the other areas around campus have access to the overhead wireless network. Then there's a MAN, Metropolitan Area Network, and that covers a large campus or city. You'll see this in some of your larger, more metropolitan areas, not really around here. And then there's a WAN, a Wide Area Network. That's going to cover a large geographic area, and it's made up of small networks. Think of Central Carolina as a whole as a WAN. Realistically, I am not going to walk from the Sumter campus to Manning, Camden, whatever, but we're all part of this same network. But geographically, we're not right on top of each other. Okay, your network topology is the arrangement of connections between the computers, also referred to as your physical topology. So there is the mesh network. So each node on the network is responsible for sending and receiving transmissions to any other node without a central point of communication. So they're all responsible for themselves. The ring network is the nodes form a ring. So it's just what it sounds like, not very popular today. Your bus network, all nodes are connected in a sequential line, again, older topology, and then the star network uses a centralized device to manage traffic on the network. Here is a diagram of your different topologies. So there's the mesh, the fully connected mesh, the ring, bus, and star. ISP, Internet Service Provider, is used to connect to the Internet. The most common types of connections are DSL and cable. Now, remember, we are not completely done with dial-up, especially in some of your more rural areas. They're just referring to the most common, not the only. Satellite is also an option. Bandwidth is the measure of the maximum data transmission rate. Data throughput is the actual network transmission speed. Latency is the delay as information is being transmitted throughout the network. So a latency, if you're measuring latency, the larger the latency, the worse it is, because that means the longer the delay. Your latency is measured by the round-trip time it takes for a data packet to travel from one source destination and back. Cable internet uses a cable modem, and it uses the existing cable lines. It's always connected, meaning it's always running. The TV signals and PC data signals share the same coax cable, and then the job of the cable modem is to convert the PC's digital signal to analog. DSL, digital subscriber line, that is used, like in our area, Farmers Telephone is known for DSL. So it's a group of broadband technologies with a wide range of speeds. It uses the telephone lines that come into your house or business or whatever, but it does not use the same exact lines as the voice. DSL is also always connected, meaning it's always running, and you can use the same phone line for voice and DSL without interfering with one another. Cable internet versus DSL. Both can sometimes be purchased on a sliding scale, meaning there's internet, fastest internet, that type thing. Cable modem shares the TV cable infrastructure with the neighbors, meaning, for example, Roadrunner is what we have in our area. Think of a pie. If I have a big pie and it's just me, I get the pie all to myself. If I share it with one other person, I get half the pie. If I'm sharing that pie with 20 people, I now get a bite of the pie. Your cable, your Roadrunner, it works the same way. The more people that use the cable infrastructure, the less of the pie, the cable pie, you actually have. So the commercials where they talk about how slow Roadrunner is, da-da-da-da-da, or how fast Roadrunner is, yes, it can be fast or slow. That's not the issue. The issue is how many people do you have to share it with? The more people you share it with, the less available resources you have. DSL uses a dedicated phone line, and you have to filter that phone line for static. The setup for both is very similar, and typically the installation is completed by the provider or the user. Most of the time what happens with either cable or DSL, the technicians from the company will come and they'll get it going as far as make sure the wires are live within the house, make sure your jacks are good. They'll probably plug in the modem, and then after that you're on your own. So it would be your responsibility to take your computer, laptop, whatever, plug it into the modem that they've provided, and then they normally have documentation and an 800 number you can call if you get stuck. Both use a PC network port or USB port to connect a cable modem or a DSL modem. Satellite provides high-speed internet connections in remote areas. It's available everywhere, including the airplane. Just be careful if you're getting your satellite on the airplane. Super, super expensive. And most of the time, at least with Delta, if you have 2 airplanes to take, so you're on one plane from Columbia to Atlanta, and you purchase the use of the internet, then you have a layover in Atlanta, and you're on another plane from Atlanta to Austin, you would have to purchase the internet or satellite a second time for that second airplane from Atlanta to Austin. The disadvantages of satellite, it requires line-of-sight connectivity, and the latency occurs when uploading. So normally downloading's not so bad, uploading not so hot. Fiber optic cable is dedicated point-to-point, no line sharing. The broadband fiber optic cable is used for television, internet data, and voice communication. Verizon uses something called Fios, fiber optic service, and the upstream and downstream speeds and the prices all vary. So it's not just one set price for all. WiMAX, also referred to as 802.16 wireless, it supports up to 75 megabits per second with the range of up to several miles. The WiMAX version 2.0 can go up to 1 gigabytes per second for fixed users, up to 100 megabytes per second for mobile users. Your WiMAX cellular towers are placed about 1.5 miles apart from each other. Sometimes it is used as a last mile solution for DSL and the cable internet technology, so it's kind of like a pinch, the Hail Mary, the last minute hurrah, whatever. Also note that some laptops have a built-in WiMAX modem to connect to 4G networks, and it's the 4G network that uses the WiMAX. Cellular WAN covers a wide area made up of cells created by base stations. Cell phone network is the competing technologies GSM, Global System for Mobile Communications, that requires devices have a SIM card that contains the microchip that holds that subscription data. CDMA, Code Division Multiple Access, do not require a SIM card in a cellular device. Right now, the fastest speed for cellular data is 4G, 4th generation technology, but note that 2G and 3G technology is used, especially here in Sumter. Here are 4 external devices a computer network can use to make a cellular internet connection. Hardware used by local networks. So there's desktop and laptop devices, hubs, switches, bridges, other network devices, and then cables and connectors that use the devices. A network adapter, that's just a direct connection to a network. It could be a network port on a motherboard or a NIC, network interface card. It could also be an external device that is using a USB port. And then the RJ45 port, it looks like a phone jack. Your phone jack is RJ11. RJ45 looks the same, but it's larger. So when you're looking for an adapter, some things you need to be conscientious of. The slot that a NIC uses, so you may need to uninstall or disable an existing network port in order to use an adapter. The Ethernet speeds vary. A MAC address is a unique address for every network adapter. It's a 48-bit unique number, and that is hard-coded by the manufacturer. Most of your adapters have status lights, and that lets you know when it's connecting, working, not working, but not all, but most. Wake on LAN wakes up the computer when it receives certain communication on the network. Okay, so here is a screenshot of a Wake on LAN that is based on the software that, and here it says Intel, so it's the Intel Power Saver and Wake on LAN options. Features to be aware of when selecting adapter continued. Quality of service, which is the ability to control which applications have priority on the network, and it must be configured on the router and the network adapter of each computer. And then power over Ethernet, that allows the power to be transmitted over an Ethernet cable. It might be available on high-end wired adapters, and it's used where electrical outlets are not available. So here's a PoE splitter, and that's to be used if the receiving device is not PoE compatible. POTS, plain old telephone service, or you probably know it as dial-up. Least expensive, slowest. It can be used travel, broadband down if you're just trying to save money, or if you just live in the middle of nowhere and that's your only option. The desktop computer modem cards provide 2 phone jacks, RJ11 jacks. Twisted pair cabling is used. That's a pair of wires and they're twisted together. If it's not twisted, it runs the risk of having that extra noise, which is referred to as crosstalk. And the latest modem standard for dial-up is version 0.92. Most hubs and switches. Most wired networks use a star bus topology. The nodes connect to a centralized hub or switch. The hub passes through a device, which is outdated technology. The switch, that keeps a table of all devices connected to it. When a frame is received, the switch searches its MAC address table for the destination MAC address, and then the frame only goes to the device with that address. So a hub just kind of takes everything and then redistributes everything whether it needs to or not. So maybe it's kind of the same thing as getting your neighbor's mail, right? You don't want their mail, they want their mail, but you're just getting it because it was just kind of a sloppy job. That's the hub. A switch is when a conscientious decision has been made, meaning I request it, therefore I receive it. You didn't request it, you don't receive it. So a switch has the ability to make decisions. Now, if the destination MAC address is not in the table, then the switch will send the frame out to all of the ports except for the receiving port. So here is a diagram. Any data received by a hub is replicated and passed on to all devices connected to it. Wireless access points and bridges. That allows a wireless device to connect to a LAN. The device communicates through the access point, can also double as a router, and it can even triple and be a bridge. A bridge is a device that stands between 2 segments of a network, and it manages network traffic between them, and it keeps a table of MAC addresses just like a switch. So a bridge is an intelligent device making decisions concerning network traffic. NAS, Network Attached Storage Device, that contains bays for holding hard drives, also includes an Ethernet port to connect to a network, and most support RAID. VoIP, Voice over IP, we have that at the school. Instead of using just the traditional phone system, we are actually using our computer network, and so the voice telephone plugs into my computer. And now, the downside, of course, as you can imagine, if our computer network is down, our phones are down. An internet appliance is a type of thin client designed to make it easy for a user to connect to the internet. Really not that popular anymore. Ethernet cabling. Twisted pair, which is the most popular. There is UTP, unshielded, and there's STP, which is shielded. UTP is the least expensive, most common. And it's rated by category, so your Ethernet cable is going to be between a Cat 3 and a Cat 6A. And it's going to consist of 4 pairs of twisted wires, which means you have a total of 8 wires. Your coax cable, that's the single copper wire braided shield, not used for networking. Your coax cable, think cable TV. Fiber optic, that is glass strands inside of a protective sheath. Your fiber optic is super, super fragile. It is excellent. It's fast, it's accurate, but it's very fragile, which means you run the risk of, you break those shards of glass, you don't have your connection. So here are some pictures of different types of connectors. More connectors. And more connectors. These are for fiber optic. Ethernet types categorized by speed. So the 10 megabits per second Ethernet was invented by Xerox in the 70s. We've moved from there to the fast Ethernet, or the 100 base T, and that uses STP or UTP, which is rated Cat5 or higher. Also, the 100 base FX uses fiber optic cable. The Gigabit Ethernet is becoming most popular choice for LAN technology, uses the same cabling and connectors as the fast Ethernet, and then the 10 gigabit Ethernet uses the fiber optic cable. So if you're going to set up a small network, you're going to need computers, switches, network cables, router, and a device that provides internet access, for example, a cable modem. When you're talking about cable, make sure that cables are not going to cause somebody to trip and fall, that they do not exceed the recommended length. So the recommended length is 100 meters for twisted pair. And then you also want to stick with cable that is rated at Cat5e or higher. Make sure that the switches that you're using are the same speed as the router and the network adapters. If you have devices that run at different speeds, your entire network will run at the slowest speed. So you're going to place the wireless access point, router, whatever you want to call it, near the center of the area where you want your wireless hotspot. For example, if it's at your house and your kitchen's in the middle of your house, you might want to consider putting it in your kitchen. Your router does need to have access to the cable or DSL modem, whichever you're using. Some tools of the trade, a loopback plug. A loopback plug is used to test a network cable or port, just to make sure it's working. Process of elimination if you're having problems. It's also used to find out which port on a switch matches up with the wall jack. Cable tester does just what it sounds like it's supposed to do. It tests cable. So if you're trying to determine, is the cable bad, is the component bad, whatever, you would use a cable tester, and there are two components, the remote and the base. Network multimeter, with that you can test cables, ports, and network adapters. You can detect the Ethernet speed, duplex status, default router on a network, length of a cable, voltage levels of PoE, and other network statistics. Many can document test results and upload results to a PC. So your network multimeters really are like the head diva of all of your networking tools, troubleshooting tools. Toner probe. Here's a two-part kit. It's used to find cables in the walls. So the toner connects to one end of the cable and it puts out a continuous tone. And then the probe is used to search for the tone within the wall. A wire stripper is used to build your own network cable that will cut away the plastic jacket or sheath at the end. And then that way you can expose the little wires inside and you can put your end over the wire, the connector over the wires, and then you're going to crimp them, and the crimper is what you use to attach a terminator or a connector to the end of the cable, and that can serve as a double duty. A lot of your crimpers are both wire cutters and strippers. Here is a crimper that can crimp RJ45 and RJ11 connections. Punch down tool. Punch down tool, sometimes referred to as an impact tool, is used to punch individual wires into slots in a Keystone RJ45 jack, which is used in a RJ45 wall jack. Patch panel. The patch panel is the device that provides multiple network ports for cables that all meet up in one location. Each port has a number on the front of the panel. The keystone jacks are color-coded for the wires to be inserted on the back of the panel, and then the punch-down tool is used to terminate or make that connection. Here is a patch panel. How twisted pair cables and connectors are wired. You have a couple different types of cables. The straight-through cable is used to connect a computer to a switch or another network device, also called a patch cable. A crossover cable is set up a little bit differently. It looks the same on the outside, but on the inside it's really not. So it's used to connect two like devices, a hub to a hub, a computer to a computer, and then the idea with the crossover cable is it transmits and receives lines, but they have to be reversed, so you're not giving the exact same thing in the exact same way, and it's being misinterpreted. Okay, the RJ45 connector has 8 pins. The 10 base T and 100 base T Ethernet uses 4 pins. Gigabit Ethernet uses all 8. Here your twisted pair cabling is color-coded. So you have your solid wire and then striped wire, and those are in pairs. And there's an actual scheme that you have to follow when you are setting up your cables, when you're making cables. Your wires have to be in a certain order based on their color. Everything would line up, and then you would have the connector go over the top, and then you would crimp it. You have to make sure that those wires go all the way to the top part of that connector to make that continuous connection. Otherwise, cable's no good. Here are the standards for wiring RJ45 connectors. They're showing you the T568A wiring scheme and then the T568B wiring scheme. Okay, so when you are going to add to an existing network, make sure you know which scheme that is being used. If you don't know, then default to the T568B because that is the most common, therefore that is one typically used. If you're having problems and you need to troubleshoot, here's a flow chart to help you out. Can you browse the web and access network resources? If the answer to that is yes, you do have network access. If the answer is no, you have to go further because you don't have access to the network. Are the lights on? Do you even have a device that has lights? Those type things. So you would kind of follow this flow chart and hopefully you would have some resolution. And here's the summary. And this concludes our chapter for CPT 209.